Now that we have an idea of how TensorFlow Lite works, let's take a look at a couple of simple coding examples. Let's begin by taking a look at how we can convert a TensorFlow saved model into a TensorFlow Lite model. In this example, we're going to train a simple model on a regression task by simulating data for the equation y equals 2x minus 1. We're going to use a Keras sequential model with a single dense layer and a single neuron to solve this problem. We're also going to train our model for 500 epochs using a stochastic gradient descent as our optimizer and setting our loss function to be the mean squared error. After training our model, we will save it in the TensorFlow saved model format. Once we have the saved model, we use the TF Lite converter to convert it into a TF Lite model, as we can see here. The last step is to save our TF Lite model to a file with the extension .tflite. Pretty simple, right? Now let's take a look at another example. In this example, we're going to convert a tf.keras model into a TensorFlow Lite model. Here, we create a tf.keras model by loading a MobileNet model that has been previously trained on the ImageNet dataset. Since we're going to use a pre-trained model in this case, we do not need to perform any training like we did in the previous example. As you can see, the next steps in this example are pretty similar to the previous one, except that now we pass the tf.keras model directly to the .fromKeras model method of the TF Lite converter. So in this case, there is no need to go through the step of saving the model to an HTF5 file. We can simply pass the tf.keras model directly to the TF Lite converter. Once we have our TF Lite model, we save it to a file with the extension .tflite, just as we did before. Now, let's see how we can convert a concrete function into a TF Lite model. Just like in the previous example, we will use a tf.keras model by loading a MobileNet model that has been previously trained on the ImageNet dataset. Then, we create a callable TensorFlow graph of our model by passing our model's forward pass to the tf.function. After we have our callable function that can execute a TensorFlow graph, we can get the concrete function by using the getConcreteFunction method. As you can see, we need to pass the tensor specifications of our model's inputs to the getConcreteFunction method. The concrete function will contain the graph that can be converted to the TF Lite model. So the next step is to convert our concrete function into a TF Lite model. This step is the same as in our previous examples, except that now we have to use the .fromConcreteFunction method of the TF Lite converter. We can also use the TensorFlow Lite converter directly in the command line to convert TensorFlow saved models and tf.keras models into TF Lite models. As you can see, in both cases, we only need to provide two arguments: the output file name with the proper .tflite extension, and the directory where either the saved model or the Keras HTF5 file is saved. As we have seen, converting our models to TF Lite models is pretty easy. Now, let's take a look at how we can optimize our models. We will do that in the next lesson.